So today we're going to be multiplying radicals. So the first thing we're going to talk about is how we actually can multiply radicals. So if we have two different radicals being multiplied together, we are going to take the like parts and multiply them. So we're going to multiply the coefficients here and get a times c. And then we would also take and multiply the radicands because those are like parts. So we would have a times c square root of b times d. After you actually multiply them, then you are going to simplify using all of your simplifying rules from before. Let's go ahead and take a look at a couple examples then, how this would actually play out. So for example 1 here, we have two radicals. They both have coefficients of 1. So what we're going to do is we're just going to take and multiply the radicands together. 2 times 8 is 16. And then after we multiply them, we are then going to simplify. So the square root of 16 is 4. So therefore, the square root of 2 times the square root of 8 simplifies to 4. We're now going to do multiplication, but with the distributive property as well. So for number 2 here, we're going to take the square root of 2 and we're going to distribute that to both terms in the parentheses. So for the square root of 2 times 5 root 2, we're going to leave the 5 out in front because it's the only coefficient. We're going to multiply the square root of 2 times the square root of 2 and get the square root of 4. Then we're going to write minus, and we're going to do now the square root of 2 times the square root of 3. When we multiply those, we get the square root of 6. Then, after we have done our multiplication, you ask yourself, does anything else simplify further? So I notice right now that the square root of 4 actually does continue to simplify. The square root of 4 is 2. And then since the square root of 4 is 2, I actually take and multiply it by the 5 out in front. So my final answer here is 10 minus the square root of 6. Let's practice another one of the distribution problems here. So we're going to take the square root of 3 and we're going to multiply that by 6 root 3 and then eventually by the negative root 2. So square root of 3 times 6 root 3, the 6 has nothing to multiply with other than 1. The square root part, root 3 times root 3 is the square root of 9. Then I'm going to take the square root of 3 and distribute it to the square root of 2. So root 3 times root 2 is root 6. And then I look for anything else that continues to simplify. So this first part here, the square root of 9, does continue to simplify. So I'm going to do 6 times 3 and get 18 for my first term, minus the square root of 6, because 6 does not break down into any number pairs. It's 3 times 2. So now we're going to go ahead and look at how this works when you have a quantity squared. Notice I have a binomial here being squared. Anytime you see that square, you're going to say, wait a second, this is that one problem she was talking about. I cannot distribute the square to each term. That does not work. So be very careful with that. When you see this square, you're going to immediately stop and write the problem twice. So you have 1 plus root 5 times 1 plus root 5. After you've written it twice, we're going to now do our distributive property. So we're going to go ahead and do 1 times 1 and get 1. You're going to do 1 times root 5 and get 1 root 5. You're going to do root 5 times 1, and the 1 again goes out in front, and then the square root of 5 has no other radicand to multiply by. And root 5 times root 5 becomes the square root of 25. After you have done your distributive property, then you look for things that continue to simplify or combine together. So for this one, I notice that I have like terms here, and I also have the square root of 25. So I'm going to combine my like terms. I have a 1 root 5 and a 1 root 5, which combine to be 2 root 5. The square root of 25 becomes just 5. And now that I've simplified that, I have like terms. Once again, 1 plus 5 is 6. And then 2 root 5 is my other one that I cannot combine with anything. So it becomes 6 plus 2 root 5. Let's try another one of those squaring problems. So let's take a look at number 5. We see that the square is up here. Oops, sorry about that. Let's try that again. We see that the square is up here. So what we're going to do is we're going to go ahead and write this twice. 7 minus root 3 times 7 minus root 3. Now we're going to do the distributive property. So 7 times 7 is 49. 7 times root 3. Now the 7 is technically the coefficient, so we multiply it by the number outside the root 3, so that becomes a 7. And then we have the root 3, so 7 root 3. The negative root 3 times 7 once again becomes negative 7 root 3. And negative root 3 times negative root 3 becomes a positive square root of 9. So step 1, multiply everything. Step 2, to find like terms. 7 root 3 and 7 root 3 can combine. Also, I can simplify the square root of 40, or the square root of 9. So I have 49 minus the 7 root 3 and the 7 root 3 become 14 root 3. And then the square root of 9 is 3. And now one more time I have like terms, so the square, or 49 and 3 combine to be 52. And then we have minus 14 root 3. So it'd be our final answer because nothing else simplifies. Okay, let's go ahead and try the next one. It's another one where we use our distributive property. We're going to do 6 times 6 and get 36. We're going to do 6 times root 2 and get 6 root 2. We're going to do negative root 2 times 6 and get negative 6 root 2. And then we're going to do negative root 2 times positive root 2 and get negative square root of 4. Something interesting here happens. The positive 6 root 2 and the negative 6 root 2, those are inverse operations. They undo each other. I also have this minus square root of 4 that I can simplify. The square root of 4 is 2. And so even though this had radicals to begin with, my final answer is just 34. There are no more radicals in my final answer because the radicals undid each other, and I just got a nice answer. So at this point in time, what I'm going to ask you to do is go ahead and try the practice problems down below. So pause it, try these problems, and after you have tried them, then go ahead and take a listen to the answers. So now you've had a chance to try these. Number 7, what we do is we multiply those together. We get the square root of 108. There are 4 x's in total. There are 2 y's, and there are 5 z's. So we multiplied all of the radicands together, and now we're going to take and simplify it. So as you kind of broke everything down, 108, you can break it down however you would like. But eventually you'll get a pair of 2's and a pair of 3's to come out. So there should be a 6 on the outside of your final answer. 2 pairs of x's. Oops. So 2 pairs of x's, 1 pair of y's, and 2 pairs of z's. And left behind there would be a 3 and a z. So we multiplied and then we simplified. For number 8, we were again supposed to do the same idea, but we were supposed to square it by writing it twice and then continuing on. And so once we wrote it twice and started to multiply, we get the square root of 25 minus the square root of 50 minus the square root of 50 plus the square root of 100. Now, each and every single one of these, now that we've multiplied, continue to simplify. The square root of 25 is 5. The square root of 50 ends up being 5 root 2. The square root of 50 is once again 5 root 2. And then the square root of 100 is, oh, and that should be a plus sign, is 10. And after simplifying, now we can combine like terms. So it's going to be a 15 minus 10 root 2 for my final answer for number 8. Let's go ahead and take a look at numbers 9 and 10 then. We're going to go ahead and distribute number 9. So 3 times 1 is 3. 3 times root 3 is 3 root 3. Negative 2 root 5 is negative 2 root 5 because we're multiplying by 1. And then the last term becomes negative 2 root 15. Now, interestingly enough, none of these continue to simplify. The square root of 3, the square root of 5, and the square root of 15 all can't break down anymore, and they also cannot combine. So sometimes you just have a messy answer, and that's just what it is. That's all we can do. And for our very last one, we're going to take 2 root 3 and we're going to multiply it by each term. So 2 root 3 times 4 root 2 becomes 8 root 6. And then 2 root 3 times 5 root 3 becomes 10 square root of 9. Now 8 root 6 does not break down more, but 10 square root of 9 does, because we know the square root of 9 is 3. So this is going to become 8 root 6 minus 30 when we multiply the 10 times the 3. So thank you very much for listening, and I hope this helped.